Hello everyone, this is Dr. Savitha M. In continuation with my discussion on BTU chemistry syllabus, now I am discussing on energy systems. In that, I will be discussing on fuel cells, where I will be talking about the introduction, comparison with batteries, construction and working of methanol oxygen fuel cell and solid oxide fuel cells. Okay, so all the rest. All the videos of this will be uploaded in the YouTube channel, My Intuition. Kindly subscribe, like, and share the videos. So now fuel cells. What are fuel cells? The name itself tells the cells which are powered by using fuels. The battery is the one which gives energy with the usage of chemicals. Right, anode material, active material, and cathode reactive material. If you in a fuel cell, the burning of the fuels are, the redox reactions will be liberating the energy. Right. So if you see the reaction, see, you can see here fuel is a hydrocarbon, you know that, and oxidant. Oxidant means it is oxygen. Okay, the process is combustion, fuel plus oxygen. What are the products? Oxidized fuel products, that is carbon getting converted into carbon dioxide. Reduced oxidant, that is water, plus energy. These are the products of a reaction in a fuel cell or a burning of a fuel. Right? Now, a fuel cell can be defined as an electrochemical cell that generates electrical energy from the fuel burning through an electrochemical reaction. This is a fuel cell. And Sir William Grove introduced the fuel cells first in 1839. So it is not very long back. Today, fuel cells are exclusively used in space research. And it can be represented as, in batteries also, an anode reactive mass, cathode reactive mass, electrolyte. Okay, now here fuel is fed into the anode chamber. Electrolyte is there. Cathode is in contact with the oxygen. That is nothing but oxygen. In all fuel cell, cathode reactive mass is common. It is oxygen, because for combustion, oxygen is required. Right. So this is how a typical fuel cell looks like. See. This is the anode, this is the cathode. They are connected. At the anode compartment, fuels are fed in, and extra fuel as well, oxidized fuel is taken out, product is taken out. In the cathode also, oxidant is fed in, and reduced oxidant will be taken out. Okay, so in the central compartment, there is electrolyte. A suitable electrolyte is taken. Right. Now, if you see the reactions, see, the electrolyte is the one which connects the anode and the reactive mother, the fuel and the oxidant. Now, the electrolyte, what are the properties? The electrolyte in a fuel cell should have very high conductivity, and for this reason, highly concentrated solutions should be taken as electrolyte. Acids and alkali are preferred based on the fuels and the oxidant used. Right. So now, anodes, electrolyte. Okay. Now the basic component next is anode and the cathode. That is the electrolyte. Now electrolyte, that is oxidation and reduction. That is redox reaction has to take place at the interface. Okay. The most commonly used electrodes are graphite, platinum, or nickel. It is made up of these materials, that is graphite, platinum, or nickel. Commonly, it is not fixed that you have to use those anode and cathode only. Okay. Now, at the anode, what is the reactive mass? Reactive mass is the fuel. The fuel undergoes oxidation to give the electrons. See, fuel gets converted into oxidized product and electrons. See, liberation of electrons is called oxidation. Therefore, it will get converted into the oxidized product after liberating electrons. Now, at the cathode, what happens? Reduction reaction takes place. That is, the oxidant accepts the electron and gets reduced. Right? See, oxidant accepts the electron, reduction reaction gets reduced. A reduced product will be obtained. Right? So similarly, you can see at the cathode, reduced products are taken out. At the anode, oxidized fuel products are taken out. Right? Now, let us compare with the battery. Okay, how the fuel cell is different from a battery. Both are energy liberating. You get energy. Both the cells are devices which gives out energy. But how are they different? Okay, now fuel cells, these are energy conversion devices. That means from the fuel energy is converted into electrical energy. Whereas batteries are energy storage devices, because you are storing electrical energy in terms of chemicals. Okay, you are deriving electrical energy by the expense of chemical reactions. Right? Now, fuel cells are not rechargeable or chargeable. As it gives a continuous current as long as the reactants are fed to the electrodes. Okay, the cell will function until and when you go on supplying energy. Supplying the fuels. Okay, fuels as well oxygen. But the batteries, secondary batteries, we have discussed this. Batteries are rechargeable. Secondary batteries are rechargeable. Next, in a fuel cell, there's a continuous movement of fuel, oxidant, and reaction products. Right? The reactants are product form the integral part of the batteries. Now, classification. Right? See, fuel cell has a anode, cathode, anode reactive mass, cathode reactive mass, electrolyte. Right? You cannot classify depending upon the anode reactive mass, because always only fuel is used. You cannot classify depending upon the cathode reactive mass, because always only oxygen is used. Okay, therefore in fuel cell can be classified on the basis of what electrolyte is taken, and is also classified on the basis of the working temperature. Okay, there are three types based on the working temperature. That is low temperature with fuel cell which operates below 100 degrees, and between 100 to 500 is regarded as intermediate temperature fuel cells, and above 500 will be treated as high temperature fuel cells. Okay. On the other hand, fuel cells based on the electrolytes is classified as alkaline fuel cell, molten carbonate fuel cell, solid oxide fuel cell, phosphoric acid fuel cell, and solid polymer electrolyte fuel cell. Okay, so there's one more electrolyte used, that is biochemical fuel cell. Okay, so now what are the advantages and disadvantages of a fuel cell? Let's first take on advantages. It has a very high power efficiency. Approximately 75% conversion is there. No objectionable emissions and are eco-friendly products, because the product will be maximum carbon dioxide and water, because fuel is a hydrocarbon. On reaction with oxygen, it gives carbon dioxide and water, which are not pollutants. Right? Next, there are no moving parts, and therefore there is no, less wear and tear. High reliability in electricity generated. Now, space required for the fuel cell is comparatively less. Now, here we are not comparing with the battery. We are comparing the fuel cell with the conventional energy conversion devices. Okay, conventional energy conversion devices, you can think about water falling from the top. It is falling on the turbines, and the turbines rotate, and it is getting converted into electrical energy. So such a setup, a very high, very large space is required. So this space required is not compared to the battery. Conventional cells, like with the fuel cell. Okay. Now the products, it produces DC current for a long time. Now, what are the limitations of the fuel cell? First one is storage of the fuel and oxidant needs extreme care, because continuously in a fuel cell, we need to supply fuels from the anode to the anode compartment and oxygen to the cathode compartment. And since they have to be supplied continuously, they have to be stored. Okay, and usage of certain fuels like hydrogen and all is needs care, because those are all explosive gases. Okay, then the electrolyte and the electrodes are costly. It gives DC current and it has to be converted into alternate current. We will be discussing on two practical fuel cells. The one of it is methanol oxygen fuel cell. We will be discussing on construction, working, and the application of methanol oxygen fuel cell. Right now, methanol oxygen fuel cell itself tells methanol is the fuel, oxygen anyway is the oxidant, cathode reactive mass. Let us discuss on this. Here, methanol is considered the fuel because it has low carbon content. It possesses a readily oxidizable alcoholic group, therefore it can be oxidized easily. It has high solubility in aqueous electrolytes. Next is construction. Always oxygen itself is used as the cathode reactive mass. Okay, methanol oxygen fuel cell, see, there is an electrolyte. Sulfuric acid is generally taken as the electrolyte. The central compartment contains electrolyte. Anode, now the anode is made up of porous nickel sheet with platinum or palladium catalyst. Okay, so platinum or palladium is coated over porous nickel sheet where it is connected to the anode terminal. Similarly, cathode. Cathode is made up of porous nickel sheet but with the silver catalyst. There is silver catalyst in the cathode. Right now, they are connected externally, and there is a provision for the inlet of anode reactive mass. Anode reactive mass is a fuel. In this case, methanol is the fuel. And cathode reactive mass, there is a provision. Cathode reactive mass is always oxygen. Okay, so now this is the basic construction. See, methanol, the extra methanol and the product also will be taken out here. Carbon dioxide and water are the products of all fuels. Okay, suppose if it does not contain carbon, for example, if hydrogen is taken as a fuel, then there will not be any carbon dioxide. And if at all it contains carbon and hydrogen, that is hydrocarbon as a fuel, the product is carbon dioxide and water. Okay, the cathode reactive mass is oxygen, which is extra oxygen, and the products are also taken out from there is an excess, there is an outlet. Okay, now fuel is methanol, anode is porous nickel sheet, catalyst at the anode taken is platinum or palladium, the oxidant taken is oxygen, and the cathode is the porous nickel sheet, the catalyst at the cathode is silver, and the electrolyte is taken, is sulfuric acid. Okay, generally preferred electrolyte for methanol oxygen fuel cell is sulfuric acid. Rather, there is another electrolyte, that is alkaline electrolyte also can be used. Okay, more efficiency is given by sulfuric acid electrolyte. Okay, now working. Now at anode, what happens? Methanol undergoes oxidation. Oxidation means carbon gets converted into carbon dioxide. Let us see the reaction. Methanol in the presence of water gets converted into carbon dioxide, liberating H plus ions and electrons. Okay, now H plus electrons enter the external circuit and reach the cathode compartment. Whereas H plus ions, it diffuses through the electrode. Okay, it diffuses towards the inner side of the electrode, travels through the electrolyte, that means through the medium, and reaches the cathode. Okay, therefore that is the reason why we have to take porous electrodes, because it has to allow the ions to diffuse through it. Right now, reaction at the cathode is oxygen gets reduced in the presence of H plus ions. Okay, see, oxygen, anyway you are feeding it with oxygen. H plus ions from the anode compartment, it diffuses through the electrode, comes to the inner side of the electrode, travels through the electrolyte, and has come near the cathode. And electrons directly from the external circuit it has come, and you are feeding with the oxygen. So the product formed is methanol, water. Right? Now the net cell reaction means it is anode reaction plus cathode reaction, and you will be getting methanol plus C. Out of the 3 molecules of water formed, 1 is utilized. Therefore, remaining is 2. Okay. So this is the net cell reaction. Okay. So here there is a mistake. I'm sorry. It should be 2, because of the 3 water molecules, 1 is consumed. So remaining is only 2. Okay. Now that is the reaction, and the methanol oxygen fuel cell will give this much, at 25 degrees, 1.186 volt, right? Which is comparable to a battery, right? This is methanol oxygen fuel cell. Now, what are the applications? It is generally used in space vehicles, submarines, automobiles. All these methanol oxygen fuel cell is used. Okay, the next fuel cell is solid oxide fuel cell. We'll be discussing on the construction, working, and applications. Right? So, solid oxide fuel cell is abbreviated as SOFC. Right? Now, this consists of a solid material as the electrolyte. Hence, it is called solid oxide fuel cell. Right? So, now recent innovation in fuel cell, in all the previous innovations, previous fuel cells, the electrolyte taken is in the form of a liquid. Okay, as we know that using an liquid as an electrolyte has a lot of limitations like leaking, corrosion, all those things will be there. But recent innovation is that instead of using liquid electrolyte, a solid material or a matrix is taken as an electrolyte. It will perform the same function. That is, it will allow the transfer of ions, right, from anode to cathode and cathode to anode. Right, but the only thing is it is in the solid state. Right, the electrolyte conducts the negative oxide ions from the cathode to anode. Right, now how it is constructed. Similarly, like you will be taking a solid oxide electrolyte. Solid oxide electrolyte is a ceramic or a polymer electrolyte. That is also another fuel cell. I've told in the classification. Now, in solid oxide fuel cell, there is an electrolyte which is ceramic based. Okay, there is anode which is made up of nickel with the ceramic material, that is zirconia, which is doped with the zirconia. Next is you have a cathode wherein lanthanum strontium manganate is taken as the cathode electrode. Right, both are connected externally. And then there is the provision for inlet of anode reactive mass and cathode reactive mass. Right, now fuel is taken. Fuel enters the anode reactive mass. Whatever fuel you are taking, any fuel can be taken. Then extra fuel and the product of the combustion or product of the reaction is water, that is taken out. Okay, now in the cathode, again air in the sense it is oxygen, it is fed in and unused gases are taken out. Maybe some products also in the reaction, if it is in the gaseous state, it is taken out through the outlet. Okay, now the anode is made up of nickel mixed with the ceramic material, and the only thing is the anode electrode should be very porous, and it should allow the fuel to pass through the electrode. That means it has to go to the electrode. Therefore, go to the electrolyte. Electrolyte is taken in the central compartment. Okay, from the anode, it has to allow the ions to fuel to diffuse through it. Therefore, it should be highly porous. Okay. Similarly, cathode material taken in a methanol, solid oxide fuel cell is lanthanum strontium manganate. Okay, it is abbreviated as LSM, and it should conduct both electrons and oxide ion, that is oxygen ion, oxide ion. In electrolyte taken is a solid oxide material generally which consists of zirconia yttria based, right? This is the electrolyte taken, and this electrolyte is a dense layer of ceramic which conducts oxygen. Okay, similar like the ions which is conducted through in an electrolyte, the ion itself moves, right? But here there is a conduction of oxide ions, and its electronic conductivity must be as low as possible to prevent current leakage. Okay, so now let's discuss on the working of solid oxide fuel cell. With an example, taking hydrogen as a fuel and oxygen, anyway, every time oxygen itself is taken as the oxidant, cathode reactive mass. Now reaction at the anode. Now the fuel cell is fed in with hydrogen gas. The oxide ions which has been generated at the cathode has come through the electrolyte and the solid electrolyte, and it has reached the anode compartment, wherein it comes in contact with the hydrogen gas. It produces water and electrons. The electrons enter the external circuit, goes to the cathode compartment where you are feeding with oxygen. They combine to form the oxide ions. This oxide ion through the electrolyte goes to the anode compartment. Okay, now this passing of electron from what is formed at the cathode towards the anode and what is formed at the anode towards the cathode is made possible by the electrolyte. Okay, in this case, oxide ions which is formed at the cathode should be transferred to the anode compartment, which is done by the solid oxide membrane. Not membrane, solid oxide electrolyte. Okay, the net cell reaction will be hydrogen at the anode reaction, oxygen at the cathode combining to give water, right? So in solid oxide fuel cell, water management should be done, because water, since we are discussing on solid fuel cell, solid electrolyte, the water will go on making it, it will be a problem. So water management should be done properly. Like a complete dehydration may lead to a decrease in the conductivity of oxide ions. At the same time, too much of water may make the electrolyte, the matrix to float. So water management is a continuous management in solid oxide fuel cell, right? Now, what are the applications of solid oxide fuel cell? Okay, generally it is used in emergency backup power for buildings. It is used in satellites. Generally, it is used in satellites and space capsules, and it is also used in automobiles. Okay, so this is what I had to discuss in this video. In my next video, I shall be discussing on the remaining topic of module 3, that is solar cells. Thank you.